Hello again, let's get started. If s is the step function, then s prime of v equals 0 for any non-integer v, while s prime of q does not exist for an integer q. Guys, what I mean by that is d by dx of big S of x is 0 for as long as you're not an integer, like -2 or 0 or +3, as long as you're a fraction with something other than positive or -1 on the bottom. Well, of course you can't have 0 on the bottom, but as long as you're a fraction whose denominator is of course not 0 and is not positive or -1, then if you're in that category, then your derivative will be 0. Now, if your denominator is positive or -1, your derivative will not exist. S of q will exist, but s prime of q will not exist. Remember from the step function. And now, of course, you can't have a denominator of 0 at all. You never can have that. But anyway, now let's talk about the step function. Remember, like s of, for example, if you got 4.99, s of 4.99 is 4, because 4 is the biggest integer that is smaller than 4.99. When I say biggest, I mean most positive. So 4 is the most positive integer that is less than 4.99, so s of 4.99 equals 4. However, s of 5 equals 5, because when you get the integer itself, you just define s of that integer to equal that integer. So even though s of 4.999999 equals 4, s of 5 equals 5. Now, keep in mind, like, of course, easily s of, let's say, 2.5 would be 2. S of 2.01 would be 2. S of 2.999 would be 2. But s of 3 would equal 3. Now, and so on and so forth. Notice that discontinuities happen at the integers because s of 2.99999 is 2, whereas s of 3 equals 3. So you're discontinuous from the left, so there's no way you can have differentiability at an integer point. However, at a non-integer, like let's say 1/2 or pi, you're fine. S of pi would be 3. And like s, notice if you pick any number to the immediate right of pi or to the immediate left of pi, you'll still get s of that number equals 3, as long as you stay, I'm assuming we're staying very, very, very close to pi. Like s of 3.14 would be 3, s of, let's just say, 3.15 would also be 3. You behave coming in from both sides. And notice you're flat. You're actually a flat line as long, you're a flat line and you're continuous, so you're going to be differentiable. And you're going to have derivative 0 because the slope of any flat line piece, if you're flat within, if you're totally flat within a small neighborhood, or when I say neighborhood, if you're within a small vicinity, I should say, then your derivative is 0. And a small vicinity on both sides, I should say. So if you're, if to your extreme, to your very teeny tiny left and your teeny tiny right, you're continuous and you're totally flat, then your derivative would be 0. Okay. And by the way, you have to be defined at that point itself, which we are here. That's not an issue. We'd have to be defined at pi itself, which we are. S of pi is equal to 3, but now s prime of pi would be 0. Okay, s of pi is 3, but s prime of pi would be 0. Okay, so that's just recall the step function. If you're rusty on that, go back and see some of the previous videos from times past. So that's what s does for you. He's flat he's either flat or he's jumping. At the integer points, he's jumping. He's not even continuous, let alone differentiable at the integer points. But at the non-integer points, he's just flat and well behaved. Talking about s here. So s prime is going to be 0 at the non-integer points, and he's not going to exist at all at the integer points. Now, later on, I might talk about one-sided differentiability. Now, s prime, there are some one-sided derivatives that would exist, but let's not go there for the time being. Let's leave that alone. Okay. So there's a step function. It's the greatest, most positive it's the greatest integer, aka the most positive integer, that is less than or equal to that particular number. Like s of 5 would be 5 itself. S of 4.99 would be 4. S of 5.01 would be 5. Okay, and you get the idea. Now the negatives, you just have to be a little careful. S of negative 5 would naturally be negative 5 itself. S of negative 5.01, now you would have to go to negative 6 because your negative 6 is the most positive number that is less than, negative 6 is the most positive integer that is less than negative 5.01. Again, negative 6 is the most positive integer that is less than negative 5.01. So S of negative 5.01 would equal negative 6. Whew. Now, S of negative 4.99 would be negative 5. With the negatives, you have to stop and think a minute. The brain, it's the same concept, but it's trickier for the brain some way, somehow. Okay, now if h is the Heaviside function, then h prime of x equals 0 as long as x does not equal 0. Now h prime of 0 does not exist, and I got bad grammar there. Let me get rid of that. The word is h prime of 0 simply does not exist, because remember you're discontinuous there. The Heaviside function, h of a positive number equals 1, h of a negative number equals 0. And h of 0, some textbooks either leave it undefined, others define it to be 1/2. You could even, technically, in any event, you're discontinuous. And to be honest with you, there's no fixing it. You could define h of 0 to be 0, or you could define h of 0 to be 1. You would get continuity from one side, but that's not going to make you continuous, let alone differentiable at 0. It's over. There's no saving h at 0. H prime of 0 will not exist. Okay, so there's that. So let's move on to other things. Now, d by dx of 2 to the x, that's going to be, remember, that's 2 to the x is e to the x ln 2. So that's d by dx of e to the x ln 2. And here comes the chain rule, right? And I forgot to, we're going to let u equal x ln 2. And I need to state that real badly, where u equals x times ln 2. And sorry about that, guys. I forgot to state that. And I got my w and h backwards. So sorry about that. All right, so ready? Let's do it. So we got d by dx of 2 to the x is d by dx of e to the x ln 2. We let u equal x times ln 2. So you could just as well, x ln 2, that's correct, but I'll make it better looking by putting that times sign between them. So e to the x ln 2, you don't have to have this times sign, it's just for aesthetics. So we got that. Now we let u equal x ln 2, so we got d by du of e to the u times d by dx of my u term, which is x times ln 2. Guys, ln 2 is just a number, okay? So that's equal to, now d by du of e to the u is e to the u times, now d by dx of x ln 2 is just ln 2. All right. But hey, remember, we got to get honest. We got to plug u back in. So that's e to the x ln 2 times the ln 2. But remember, wait a minute now, remember e to the x ln 2, that's 2 to the x from algebra. So that's just 2 to the x times ln 2. And then, of course, from the beginning, u has been that. This boils over. If you can replace these 2's with 3's or pi's or 1/2 or 2/3 or 5/3 or whatever. Just so you stay positive. Don't use 0 or the negatives. I don't want to. You would run into some weird stuff. Let's not go there. Greater than 0, we do, again, the u substitution. And again, where u equals, it's going to be c. No, wait, it's going to be x ln c. Okay. And then, so we have that. So u equals x ln c. So I can replace 2 with 3 or 4 or the letter C. So d by dx of positive c raised to the x, you just do e to the x ln c. You do the chain rule where u equals x ln c, and you just get all this stuff right here. Now, of course, c is understood to be positive, all right? Yeah, it would be a disaster otherwise because we'd get the ln of a negative. And we know we can't do ln 0. We can't do ln of a negative, so c has to be positive.